Look around you. Really look. What do you see? A vibrant tapestry woven from countless hues, an explosion of red, blue, green, yellow, orange, violet. The deep cerulean of the sky, the emerald leaves on a tree, the warm glow of a sunrise painting the clouds in fiery streaks. Color, it's not just a characteristic of the world. It's an intrinsic part of our experience, shaping our emotions, guiding our decisions, defining beauty itself. It's in every brushstroke of a masterpiece, every blink of a traffic light, every delicious shade of ripe fruit. It's so fundamental, so ever-present, that we rarely stop to consider its true significance. We wake up to it, live in it, and take its presence for granted, an unspoken constant in the symphony of our senses. But what if one day you woke up and it was gone? Not faded, not muted, but utterly, completely vanished. Imagine a world where the spectrum collapsed, where every single hue, every shade, every tint simply ceased to exist. What would remain? A universe rendered in an infinite, stark gradient of grays, from the deepest charcoal to the palest silver, an achromatic silence where once there was a chorus of pigment. This isn't just a philosophical thought experiment. It's an exploration into the very fabric of our reality, our perception, and our understanding of the cosmos. Join me as we plunge into the monochrome abyss and ask, what if colors vanished? Our journey into this colorless void begins with understanding what color truly is. It's not an inherent property of an object itself, but rather a dance between light, matter, and our brain. When light, which is a form of electromagnetic radiation, hits an object, some wavelengths are absorbed while others are reflected. The wavelengths that bounce off are the ones our eyes perceive. Our retinas contain special cells called cones, tuned to detect specific ranges of these wavelengths, sending signals to our brains, which then interpret them as red, green, or blue. Mix these primary colors in different combinations, and we perceive the entire spectrum. So, for color to vanish, something fundamental would have to change. Either the light itself would cease to contain different wavelengths, becoming monochromatic, or, more likely and perhaps more terrifyingly, our ability to perceive and interpret those wavelengths as distinct hues would simply shut down. The world would still be bathed in light, but our internal processor for color would be irreversibly broken, leaving us in a universe of grayscale. The immediate impact on human life would be nothing short of catastrophic. Think of the sheer psychological weight. The vibrant tapestry of human experience would unravel, leaving behind a stark, colorless void. Art, as we know it, would be fundamentally redefined. Imagine a world without Van Gogh's swirling star-filled nights of deep blues and yellows, without Monet's impressionistic gardens bursting with light and shadow, without the fiery passion of a Rothko painting. The very essence of beauty, often tied to color, would be stripped away. Fashion would become an exercise in texture and silhouette, a silent rebellion against the monotony. Food, so often judged first by its appealing hue, the ruby red of a strawberry, the golden crust of bread, the vivid green of fresh vegetables would lose its visual allure, impacting our appetite and enjoyment. Would an unripe, bitter green banana taste the same if it looked like its perfectly ripe, sweet gray counterpart? Our emotional landscape would undoubtedly shift. Color psychology is a real field. Red often signifies passion or anger, blue evokes calm or sadness, yellow joy. Without these visual cues, how would our moods be influenced? Would the world feel perpetually muted, a constant undertone of melancholy? Beyond the sensory and emotional, the practical ramifications would plunge society into chaos. Traffic lights, those universal arbiters of movement, would be rendered useless. Red for stop, green for go, these are concepts ingrained in our consciousness, not just by shape, but by their distinct, urgent colors. Imagine the gridlock, the accidents, the sheer paralysis of urban transit. Warning signs, medical indicators, and even simple navigation would become incredibly difficult. How would we distinguish between different medications without their color coding? How would doctors diagnose conditions like jaundice or detect bruising, where color changes in the skin are critical indicators? Firefighters rely on the color of smoke to gauge the intensity and nature of a blaze. Without it, their jobs would become infinitely more perilous. Even everyday tasks, like identifying ripe fruit in a grocery store or choosing clothes, would demand an entirely new approach, forcing us to rely on texture, shape, and context alone, which in many cases would be insufficient. But the vanishing of color wouldn't be confined to our terrestrial existence. Its absence would send ripples across our understanding of the entire cosmos, irrevocably altering how we perceive and study the universe. For astronomers, color is not merely aesthetic, it's a profound data point. When we gaze at the night sky, the colors of stars reveal their temperature and composition. Blue stars are hotter and younger, while red stars are cooler and older. Without these visual cues, this fundamental classification becomes incredibly complex. How would we differentiate between a blazing hot supergiant and a dying red dwarf if they both appeared as identical shades of gray? Nebulae, those vast cosmic nurseries where stars are born, are often depicted in breathtaking, vibrant hues, each color telling a story of the elements within hydrogen glowing red, oxygen glowing blue-green. These colors are not merely artistic embellishments, they are scientific data, captured by sophisticated instruments that measure specific light wavelengths. If color perception vanished, these ethereal clouds would lose their distinct visual identities, becoming indistinct smudges of gray. Our current understanding of star formation, the distribution of elements in the galaxy, and the very chemistry of the universe would be severely hampered without the spectral information that color provides. Imagine the iconic pillars of creation, reduced to dull, uniform columns, their majesty diminished, their scientific story obscured. Furthermore, consider the implications for phenomena like redshift and blueshift, critical tools for measuring the expansion of the universe and the movement of galaxies. Light from distant galaxies is stretched, shifting towards the red end of the spectrum as they move away from us. The greater the redshift, the faster they recede. Conversely, objects moving towards us exhibit blueshift. While astronomers use spectroscopic analysis of light wavelengths to quantify these shifts, the very concept of red or blue shift and the visual intuition it provides would lose its meaning. Our ability to grasp the dynamic, ever-expanding nature of the cosmos would require a radical reimagining of our interpretive frameworks, relying purely on numerical data without the intuitive visual aid that color provides. Even the search for exoplanets and the potential for life elsewhere would be impacted. Scientists analyze the light passing through an exoplanet's atmosphere to detect the presence of certain gases, which absorb specific wavelengths, leaving telltale color signatures. These spectral fingerprints are crucial for identifying biosignatures, like oxygen or methane, that could indicate life. Without the ability to differentiate these wavelengths as distinct colors, this method would lose its visual shorthand, making the interpretation of complex spectral data far more abstract and less intuitive. We would be left with raw data, requiring a complete overhaul of how we visualize and understand the atmospheric compositions of alien worlds. In a world devoid of color, humanity would be forced to adapt. Our other senses would likely heighten, or we would develop new technologies to compensate for the loss. Perhaps instruments that translate specific wavelengths into tactile vibrations or auditory tones, allowing us to feel or hear the differences we once saw. Imagine a color detector that emits a low hum for red, a high-pitched tone for blue, and a rhythmic tap for green, transforming the visual into a symphony of sensory input. Our brains are incredibly adaptable, and with time, new neural pathways might form, allowing us to process and interpret the world in entirely novel ways. Design and architecture would find beauty in form, texture, and light manipulation, celebrating the interplay of shadow and illumination. Black and white photography, once an artistic choice, would become the sole visual record of our existence, valued for its stark honesty and timeless elegance. The focus would shift to the subtleties of contrast, the nuances of reflection, and the intricate patterns of light and dark. Our language, so rich with color metaphors, feeling blue, green with envy, seeing red, would have to evolve, or these expressions would become archaic remnants of a forgotten sensory past. This thought experiment also forces us to confront a profound philosophical question. Is color truly out there in the universe, or is it merely a construct of our minds, an interpretation our brains impose upon the raw data of light wavelengths? The consensus among scientists is that while wavelengths are a physical reality, the subjective experience of redness or blueness is indeed a product of our biological machinery. Other species perceive color differently. Some birds and insects see into the ultraviolet, while many mammals see a more limited spectrum than humans. What if our entire perception of color is just one interpretation among an infinite number of possibilities, a unique translation of the universe's inherent complexity? The vanishing of color would highlight the fragility and wonder of our particular sensory experience, reminding us that our reality is shaped as much by our internal biology as by external physics. It would underscore the fact that the universe, in its rawest form, might not be colored at all, but rather a dance of energies and vibrations that our senses elegantly translate into the vibrant masterpiece we call reality. The loss of color would be a testament to how profoundly our perceptions shape our understanding of existence, stripping away not just a visual attribute, but an entire dimension of meaning, beauty, and scientific insight, leaving us to navigate a universe forever muted.